So here we have a lesson on abstract half angles. First, let's refresh our knowledge of the half angle identities, or what I called the uglies. Okay, so when we have sine of half angle, these are the half angle rules, we're going to go ahead and do a calculation with a full angle. Remember how it looked? Plus, minus, big square root. What's in the bottom? A 2. Now it's 1. Is it plus or minus for sine? It's minus because it's cosine of the full angle x. Okay, let's do it again. Plus minus the square root of fraction. What's in the bottom? A 2. Looks kind of like this formula. 1, but the cosine of half angle gets plus because it matches cosine of full angle x. And tangent is plus minus the square root of. Tangent is sine over cosine, so that would be 1 minus cosine of x over 1 plus cosine of x. Now that's an easy one to derive from those two, but this is not the easiest one to calculate with. You have to simplify a radical, multiply by conjugates, rationalize. So there's a couple more formulas here. If we take the bottom, 1 plus cosine of x, then what goes on top? Sine of x. Okay, that's a good formula, not the best. What if I take the numerator, 1 minus cosine of x, and the bottom would be sine of full angle x? And this is the one I highly recommended. That one has the easiest denominator for rationalizing, and the calculations are the most simple. You also don't have to pick the plus or minus sign correctly. It'll just work out the right way. All right, how about half angles? We talked about this yesterday. If the angle starts in quadrant 1 or 2 and you chop it in half, where will it be? It will be in quadrant 1. But if the angle starts in 3 and 4 and you chop it in half, all of those angles, they both go to quadrant 2. So everybody either ends up in quadrant 1 or quadrant 2. And then some people are even noticing some things. Since you go to quadrant 1 or 2, for all of these problems right here, isn't the sign always going to be positive? Well, yeah, because if you're in quadrant 2, you're going up. If you're in quadrant 1, you're going up. So the sign is always going to be positive. The cosine could be plus or minus depending quadrant 1 or 2. Okay, so how does this work? Alpha is in quadrant 2. So let's just draw the full angle. The full angle is in quadrant 2. So the half angle is going to be in quadrant 1. Quadrant 1. So for sine, would you pick the positive or the negative? We're in quadrant 1, remember. Here's half angle. So let's pick positive for sine. What about the cosine of the half? Here in quadrant 1, so pick the plus, and tangent would pick the plus, or use the formula, but you don't have to pick anything. What if alpha is in quadrant 4? So if the full angle is in quadrant 4, where is the half going to be? The half is going to be in quadrant 2. Okay, you're in quadrant 2. Sine is positive. Cosine is negative. Tangent would be negative. That's how you determine the sign. And these are the signs that would go outside of the big square root. Okay, that's the sign you're trying to determine, plus or minus. Okay, today we're going to do some half angle problems. Same rules as yesterday, except we're not using unit circle. We're going to be drawing our own pictures. Okay, so it says here that alpha is in quadrant 3. Okay, so let's draw full alpha in quadrant 3. Okay, here's full alpha. Sine is opposite over hypotenuse. Does the negative sign go on the 3 or the 5? Well, it never goes on the hypotenuse, so let's put it there. And, oh, this one's nice. It's a 3, 4, 5. So let's put, what did you say? Negative 4 on the adjacent leg. Now, this is alpha. This is the full angle. So if this is the full angle, starting in quadrant 3, where would the half angle be? The half angle, when you chop angles in quadrant 3, they go to quadrant 2. Okay, the half is in quadrant 2. So when you're doing these problems, cosine of half, let's pick the negative sign. For sine, let's pick the positive sign. Tangent would be negative, but we're going to use the formula you don't have to pick. All right, let's start with cosine. Cosine of half alpha. It says pick the negative sign because the half angle alpha over 2 is in quadrant 2. Big square root. There's a 2 in the denominator, and it's 1 is a plus or minus. Plus cosine of full alpha. Okay, so let's just put a little note here. This is determined by the half, and right here you write down the full angle. Okay, now yesterday we wrote things like cosine of pi over 4, but now it says cosine of full alpha. Well, what's an alpha? Luckily you have an alpha picture right here to work with. So let's go ahead and do some calculations here. 1 plus the cosine of alpha is negative 4 over 5. Negative 4 over 5. How should I write a 1? Let's write him as 5 over 5. How should I write a 2? Let's write that as 10 over 5. It's a lot of denominators of 5 because you know what happens, right? All those 5s are going to cancel out. So we have negative square root. 5 minus 4 is 1 over 10. Okay, did you guys know that a radical 1/10 is the same as radical 1 over radical 10? You can give them each their own radical. Not when you're adding. So this is negative 1. But let's not write radical 10 in the denominator. Let's rationalize. Negative radical 10 over 10. Okay, now we have to find sine of half alpha. So the sine of half alpha is, should we pick plus or minus? Remember, the half is in quadrant 2, and in quadrant 2 it goes negative, positive, so we're going to pick the positive sign. Inside the radical, it's 1 minus the cosine of full alpha. So this is a half angle, this is a full angle. And this is not unit circle, this is picture. This is a random alpha picture. Okay, here we go. 1 minus cosine. Cosine is negative 4 over 5. And this is all over 2. Negative is going to cancel to positive. Let's write 1 as 5 over 5. Let's write 2 as 10 over 5. Okay, so now we have the square root of 9/10. Radical 9 is just a plain 3. Oh, but let's not write radical 10 in the bottom. Let's rationalize and say radical 10 over 10. Does a regular number cancel with a radical number? No. Regulars with radicals with radicals. Okay. And less than tangent. Now, there's a couple ways you could do this. You could use the formula for tangent, and the one that I highly recommended was 1 minus cosine of full alpha over sine of full alpha. But since we just calculated the sine and the cosine, what we could do is we could do the tangent of half alpha using the sine of half alpha and the cosine of half alpha, because tangent is sine over cosine. So let's put 3 radical 10 over 10 divided by the cosine, negative radical 10 over 10. And so the denominators cancel 3 radical 10 over negative radical 10. And a radical can cancel with a radical, and so the final answer is negative 3. I'm pretty sure that's the same answer we'd get had we done the problem this way. If we had done it this way, what would that have looked like? 1 minus the cosine of alpha is negative 4 over 5. And the sine of alpha is negative 3 over 5. So let's see. We cancel negative, make a positive. Let's write this as 5 over 5. So we have 5 plus 4 to make a 9. All the 5s are going to cancel out. 9 divided by negative 3. Yep, we would have gotten the same answer. This one did not have a lot of radicals, so either way was rather simple. Okay, Let's try one more. Okay. Tangent of alpha, where alpha is between 3 pi over 2 and 2 pi. What quadrant is that? Yes, that's quadrant 4. So let's draw our full alpha picture in quadrant 4. Remember, origin into the quadrant x-axis. Here's full alpha. Tangent is opposite over adjacent. Radical 2 over 2. And which one gets the negative? Do they both get negative? Well, then they'd cancel out. So no, just one of them. And I'm going to put it on the one going down. All right, let's do a little Pythagorean theorem. 2 squared plus quantity negative radical 2 squared equals c squared. 4 plus positive 2 is c squared. And so the hypotenuse is radical 6. Okay, it is time for some half angles. Where is the half angle going to be? This is the full angle alpha. And so if you start in quadrant 4, then the half goes to quadrant 2. Here's where the half alpha would be in quadrant 2. Sometimes I like to draw the picture so that I realize, oh, in quadrant 2 it's negative, comma, positive. Up here, sometimes I like to write a hint so when I start to do the formulas, I have the answers already. Cosine for half, let's pick the negative sign. Sine for half, let's pick the positive sign. And tangent is going to be negative. Okay, that happened up here too, right? Yeah, absolutely. The tangent is negative, and I told you you didn't have to pick it, but it's a great way to check. Did your answer for tangent of half angle come out negative? So the answer for tangent right here was negative. Perfect. That means it worked. Okay? All right, just a little check to make sure everything's going right. So let's start by doing cosine of half alpha. Cosine of the half angle. Let's pick negative, big radical, 1 plus cosine of the full alpha, all over 2. So that's going to be negative square root of 1 plus cosine is 2 over radical 6. Now I'm going to tell you, we could write 2 over radical 6. But if we rationalize now, it'll make our calculations a lot easier later. So let's go ahead and rationalize this here in the corner before we work with our answer. So 2 radical 6 over a plane 6. Can you cancel a plane number with a plane number? Absolutely. So I'm going to write radical 6 over 3 in my calculation. Let's zoom in. It might be a little tight for people to see here. Okay, and then this is all over 2. So how should I write that 1? Did you say 3 over 3? Great. And let's make this denominator 3. So that makes this 6 out of 3. Okay, all those denominators cancel out, and so we have negative square root of 3 plus radical 6 all over 6. And I think we're just going to leave our answer like that. Okay, when you're doing the uglies, let's just keep them ugly. Otherwise, we'd have to rationalize within the radical, and it just becomes a big mess. Okay, if you can do the half angle formulas, you're looking good. All right, let's do cosine or sine. Sine of half alpha. Sine of half alpha. We're in quadrant 2. The sine's positive. I said I was going to pick positive, so I will. Inside, it's 1 minus cosine of alpha over 2. All right, here comes our calculation. 1 minus. What's the cosine of alpha? Now, one of the great things about the uglies is we've already figured out what cosine of alpha is up here. So if you do one problem, we can just write that cosine answer. Radical 6 over 3 again. The only difference is this time we have a minus in our calculation. So how should I write the 1? I hope you said 3 over 3. And how are we going to write the 2 over 1? As 6 over 3. So final answer is the square root of 3 minus radical 6 all over 6. Sometimes when that's a 4, I'll take it out of the radical, but when it's a 6, let's just leave it alone. Okay, now for tangent. Tangent of half alpha. Now I know that we can do the trick, and we could take this sine and divide by this cosine. But then we're going to have radicals within radicals, and I'm not sure that's the best way. I think the easiest thing here would just be to use the formula. 1 minus cosine of alpha over sine of alpha. So I'm going to do that. 1 minus cosine of alpha. Oh, there it is again. Radical 6 over 3. Sine of alpha, we haven't figured that out yet. So let's go find the full alpha picture. And sine is opposite over hypotenuse. That's negative radical 2 over radical 6. Okay. Now we can cancel radicals. The reason why is radical 6 is radical 2 times radical 3. So what you're doing essentially is canceling a radical 2 from each of them. So I guess the answer is negative 1 over radical 3. Oh, let's not write that here. Let's write the rationalized version, negative radical 3 over 3. How should I write that 1? How about 3 over 3? Okay, so we're getting there. So now we have 3 minus radical 6 over negative radical 3. Now this one we do have to rationalize. It's not stuck inside of a radical. So let's just multiply top and bottom by radical 3. Okay, not the negative. That's not rationalizing. You just multiply by the radical. So what does the numerator become? First we have 3 radical 3. Then we have minus radical 18. Can't radical 18 be simplified? Or maybe we should think of radical 6 as radical 3 times radical 2. So that means a 3 can come out, but the radical 2 stays like that. And in the denominator is negative 3. I'm going to give them each their own negative 3's. So the final answer is, cancel, cancel, negative radical 3, cancel, 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 plus radical 2. If you don't like that, you could always say radical 2 minus radical 3. And there's your answer. Once again, these formulas are not easy, so please turn the page, write down all the formulas, most of them hopefully by hand without looking. Have a great day.